Hey, welcome back. This time, now we've looked at setting up our OpenGL environment, and we've looked at getting the Torus code running. This is the Torus function, what do you call it? The Torus project here, and if I start playing it, I'll see my beautiful brick donut here. All right, so Um, that's all well and good, but this is quite a lot of code just to get a donut to show up, isn't it? I mean, we've got all this stuff in Torus, we've got all this stuff in utils, we've got these shaders, and we've got all the stuff in main. So we're going to take a quick look at what some of this GL-specific code is and what it does, because a lot of the function calls are not intuitively named, which is, fine. It's the nature of the beast, I guess. So, before we get started, it seems like there's some general confusion on what exactly OpenGL is and how it works, and how it works with VAOs and VBOs and binding and that sort of stuff. So, uh, one way I like to think of it is GL is you often hear it said that GL is state-based. It's a state machine. What does that really mean? If you've never worked with a state machine before, it can be kind of a little tricky to grasp your head around. But basically, we can think of OpenGL kind of as like a mechanic or whatever. Insert metaphor here, but I like the mechanic one. In that he can do a lot of things to a car, but you need to tell him, he has only one lift, and so he can only lift and work on one car at a time. So you have to tell him which car you want to work on. If I just tell him, okay, these are the vertices, these are the whatever, he doesn't know what car I'm talking about. So each of the cars is a VAO. Each, you can almost think of it like a class in your Java or whatever, in that it's not necessarily a singular car, but it is a singular configuration of cars. So maybe like all Honda Civics are one VAO or whatever, or all. And then binding the VAO to OpenGL is kind of like putting that car on the lift. And then adding those, all those VBOs are different characteristics of the car. So maybe one VBO describes the shape of the car. This one's got like a little round hood or whatever, and it's got 2 windows. Another VBO maybe describes the color of the car. So this one's red all over except for the tires. And then whatever. Another VBO can be another characteristic. Whenever we're done setting all that stuff so that the mechanic's finished working on our car, we can bind another VAO, and now we are setting up another car. Okay, so the VAOs are each type of object. The VBOs are attributes or characteristics of that object. And we'll talk a little bit more about what that actually means and looks like later. Okay, so you open up main, and I just realized that I'm not doing this in 2K, so I'm going to switch over to that real quick. Okay, so now that resolution's better, should be easier to read the text, just in case. I'm going to zoom in a bit. Okay, so we open up the main file, and gosh golly, that's a lot of stuff. So where do we start here? All right, first thing we're going to look at is just all of these global variables. Okay, so these first things, these are just defining the camera and the torus locations. the X, Y, and Z are stored individually instead of in an array. That's kind of up to just dealer's choice, you know. Now, these are a little more interesting. The rendering program, I believe, is actually the shader. Yes. So a lot of stuff in OpenGL is referenced by an integer. You see this this whole glue int, that just means GL unsigned int. So it's just an identifier that GL knows on the back end is associated with a certain thing. So we're going to associate whatever shader we compile with the whatever number gets generated for a rendering program. You can kind of think of it like an index into an array, or maybe an index into a dictionary, something like that. Similarly, we create an array of VAOs and VBOs. So we've defined here our number of VAOs and our number of VBOs. We've created an array of one, so you know, it's just one thing. And then there's 4 VBOs, which are going to be associated with that VAO. So again, we've got, you know, VAO, one VAO meaning one object, which is going to be our donut, and 4 VBOs, which is 4 characteristics of that donut. All right, then we have another glue int that is the brick texture. This is another thing where it's just associated with it, so we've got another integer that associates on GL's backend with a loaded texture file. Then these are the mvlock and projlock are, it's a little more complicated. These are what is associated with, I believe, the projection matrices in the shader. Yeah, so we have 2 uniform variables here, one for the MV matrix and one for the projection matrix. And this is going to keep track of where those are in the shader. Don't think about that too much right now. We're going to get to that in a second. Width, height, aspect, it's all just about the window. And then we've got matrices for each of our different, you know, matrices. I believe this is the projection matrix, the view matrix, the model matrix, and the model view matrix, which is the combination. Don't mind the mmat2. That is just, yeah, don't worry about that. Okay, the torus. We're not going to look at the torus much because the torus isn't super GL specific, but if we look in Torus CPP, we can see what's happening when we call Torus myTorus. So we are defining a torus. We're basically making this function call here and giving it, geez, what is it? 0.5 at the inner position, 0.2 at the outer position, and 48 precision, which is just going to define some bits about some bits of info about the about how the torus looks. You can play around with these values and it will adjust what the torus looks like. I recommend you do so. Now, okay, that's all of our global variables. Don't worry about this, it's just a function to get radians. Duh. Now we're going to go all the way down to main. Now let's talk about your typical OpenGL process. So the typical OpenGL process or structure is going to look like this. Pretty simple. You're just going to initialize your libraries. Here that's our GLFW, our GLEW, any other libraries that we have, especially for whatever program we're making. Then we're going to initialize our objects. That means telling OpenGL what each of those objects is, you know, binding the VAOs to it so that we can draw them later, telling them all of the characteristics of that object, or binding the VBOs. And then we do that at the start, so we don't have to be rapidly accessing GL's memory all the time later on. And after this is done, GL should know what all of our objects look like. Then we enter our game loop. This is typically a like while true, basically, or while the person hasn't indicated that they want to stop or close the window. And we're just going to process input and draw everything to the screen. We look back at our code, and wouldn't you know it, this is all just setting up the libraries. So we initialize GLFFW, we initialize glue. We set up the window. That's typically just kind of standard. You can set the window to whatever size you want, and don't worry about that function too much. Then GLFW has a number of callbacks that you can register for stuff like, say we resize the window. If you don't set something for resizing the window, it might not know what to do with it, and so your results will look kind of wonky. So this is just going to tell it what's going to happen whenever you resize the window. And it's going to go to this window size callback function, and it's going to adjust the perspective matrix. Don't worry about what that does. All right. Then we do our initialization step. So init window is where we're going to set our shader. We're going to set our camera and torus positions. We're going to set up the vertices for the torus, and we're going to set up our texture, all of that good stuff. We'll go into that in a second. Then we get into our game loop. We look until the window should close, be that from Alt F4 or the X button or whatever. And they have it swapped here. They display or render everything to the screen first, and then they poll events. I'm sure there's some discourse on which one you should do first that you probably get to in the class. And then afterwards, it's literally just closing everything. All right. So the exciting stuff is what happens in these two functions, right? Your init and your display. That's where all of the weird OpenGL stuff gets thrown at you. So let's look at init first. If we look at init, we have used our utility stuff to load in the shaders. We're going to look at the shaders a little bit in a second, but you probably know that shaders are just the way that GL processes all of the vertices and actually does the rendering to the screen. We'll talk about that later if needed. So it's going to take vert shader and frag shader, and it's going to associate that with the ID rendering program. You can look at create shader program if you'd like. I just pressed F12 there. But it's not super interesting. It's just going to load those shader programs and then attach them and stuff, and it not super exciting. You can just kind of use this function for a while without really knowing what it is, what it's doing exactly, at least for vertex and fragment shaders. All right, we set positions. That's not super exciting. We set up our frame buffer. That's pretty standard. We just tell it the width and height of our window, and we, if you know how a frame buffer works, it's basically you're drawing to the buffer, and then you're swapping the buffer to the main screen. So that's just got something to do with that. You'll probably just do that each time. Don't worry about it too much. Then we set up our perspective matrix. Um, GLM will do that for you. You do need to know how to do that in terms of like, your general graphics knowledge, but for our purposes here, don't worry about it. Then we get into setup vertices. We'll get into that in a second. Then we load the brick texture again. You don't need to worry too much about how load texture works. It's going to use soil to get the texture loaded and associated with the texture reference that it returns. So you send it in the path to a, or the relative path to a texture, and it gives you a reference integer that you can then like tell it to use later on. All right, then we bind the texture, which just tells us like, create this texture, set up this thing as a texture in OpenGL. All right, now the weird stuff, set up vertices. Okay. Everything up here is generating arrays of information for our VBOs. Okay, so we've got 4 VBOs, remember, and we've got 4 things that we're getting from the Torus. Remember, we've already created the Torus up here in the Torus thing in init. This is where it's actually calculating all of those normals and UVs and vertices and etc. And after that, we have an array of vertices, an array of UVs, an array of normals, and our index list. Okay, hopefully you know what that is from the lecture. A vector, if you don't know C++, vector's just like a list or whatever in Java, an array list or a list in C#. Basically a dynamic array, so you don't have to worry about the size. Okay. Then we're going to go through the vertices and just flatten them out, basically. We're going to push them as x, y, and z so that we don't have instead of having a vector representation, so it's like a 2-dimensional array, we want to have just a flat 1-dimensional array of x, y, z, x, y, z. Same thing with our texture values and our normals. So say we had 30 vertices in the torus. It's definitely too low, but imagine. We would then have 90 vertex numbers in our p-values, which I think just means position values, 60 in our t-values, and 90 in our n-values. All right, now the GL stuff. Ooh, it's got me thirsty. All right, anytime we want to create a VAO for OpenGL, we're going to do this kind of process. We're going to create the data for the new object. We've done that with the torus. We created the index list, we created the vertices, we created the blah, blah, blah. Then we're going to create a VAO in GL's memory. We're going to tell it, hey, mechanic, we're ready up your lift. I'm about to put a car there. Then we're going to tell GL that we're working on that specific VAO. That is our binding process. Then we're going to create the VBOs. We're going to tell it, okay, it's going to have, I'm going to create this many buffers, and for each of those buffers, I'm going to tell GL that I'm working on that buffer specifically. Then I'm going to associate data with that buffer, or fill up the buffer, basically. And then I'm going to tell GL how you read that data. It doesn't need to know like specifically what it is, but it needs to know the dimensionality. It needs to know if this is, a if I should expect like an X, Y, and Z, and then repeat X, Y, and Z, or if I should expect like a UV, repeat UV, repeat UV. Okay. Let's see how we do that in the code. Okay, so we gen vertex arrays. That's our this takes two parameters. We're going to tell it I want one VAO, and I want the references to be stored in the VAO array. I believe you need to pass this an address, which is why it's an array, because arrays are basically just pointers, which is just an address to memory. Okay, C++ stuff, fun. Then we bind that array. So we've put one VAO at, it's going to be stored at VAO sub 0, because that's the start of the VAO array. And we're going to bind whatever we just, whatever that VAO we just created is. Then we're going to generate our VBOs. Just like I said, we've got 4 of them, so we're going to tell it to generate 4 VBOs and put those identifiers in the VBO array. So now we're going to be able to access, VBO 0 through VBO, oh my god, I can't type, 3. And that's going to be some integer value. Okay, then I go through each one of these. I'm going to bind the buffer. I'm going to tell it what kind of buffer. It's just an array. It's just an array of data. That's all this means. And then I'm going to tell it bind this first VBO. Okay, so in this case, my first VBO is going to be my position values. That, I believe, is kind of arbitrary. You can mix and match them, whatever. But for this, we're saying that this is the position values here. We're going to call GL buffer data to actually load the data into that buffer. We're going to say that it should be of p-values size, the number of p-values times 4, I believe, because it's 32-bit numbers or 4-byte numbers. I'm going to say that the third variable is the address, so I'm going to give it the address of the first value of p-values. So it knows now how much to read, right? Because it can read from the start of p-values to the end of p-values. Okay. Then GL static draw, don't worry about that too much. It's just telling us that this is going to be used for drawing, and we don't expect it to change very much. All right. Now we're done with our vertex VBO. Now we're going to move to our UV VBO. It's kind of confusing. Now we bind that second VBO. We do the same thing with t-values, and we move on. So every time we bind a buffer, it's going to take the old one out of the bin and put the one that we want into the bin. So now it just knows that every call after this, we are specifying that it's on this VBO instead of this VBO. So order matters. You definitely can't do all 4 of your binds and then do all 4 of your buffer datas. So I'll give it my UV data. Then I'll do the same thing with my VBO gosh, my normals. Yeah, that's it. Then I'll do the same thing with my normals, basically the same exact code. Then this last one is special. We're going to bind data to the buffer, but we want it to know that it's an element array, which basically tells GL that it's the index list for the vertices. You know, the index list is like, okay, you want to draw the triangle with the first vertex and then the third vertex and then the fourth vertex. That's like one triangle. And then the third vertex and the fourth vertex and the 10th vertex. That's another triangle. Okay. So yeah, if you want to load the index array, you set bind buffer with the GL element array parameter, and you bind the buffer in the or you bind the data to that buffer in pretty much the same way, just you have this new specification instead. Okay, so it's a lot of like kind of confusing functions, and they don't explain what the parameters should be. But once you get down what binding and buffer data and all that means, it becomes way less monstrous. Okay, now we have created our VAO. It now knows what it's drawing when we want to draw that VAO. Isn't that exciting? Except, we didn't tell GL how to read that data. Interesting. Okay. Well, there's a couple of quirks in this file specifically. If we go down, now we've finished init, and we go down here, we're going to go into our game loop and look at display. Here we've passed it the window that just lets it know what window to draw to and the current time. I don't even know if this uses current time, but I don't know. It's good to know the time, I guess. Okay. Now, how are we going to actually draw the object? We have our VAO set. We know that, VAO1 is that torus that has all of those VBOs associated with it. So when we tell GL to draw that VAO, it's going to know what to do. But how do we get GL to know to draw that? Okay, probably just said the same thing like 3 times. So up here, this is just setting the clear color. That's just, whatever color's in the background. I believe 000 is just black. Hope I didn't break it. Yeah, and I don't know, if I set this to like 1, that would probably make it red. Ooh, disgustingly red. Hurts my eyes. Okay. Then I'm going to tell it GL use program. Program in GL is kind of synonymous with shader. So remember, we created rendering program when we created that shader program. Now, rendering program is our ID that points to that shader. So we're just telling GL that we're going to be using these 2 shaders over here, our frag shader and vert shader. Now, what is GL get uniform location? And for that matter, what is GL uniform matrix? And vertex attrib pointer? And all of this stuff that appears to be looking into the shader. So let's stop dancing around the issue and go take a look at our shader. Okay, so this is our vertex shader. Now, in the shader, this is pretty simple, but it's also very foreign looking. At the top of this, we are telling it what we expect to receive as VBOs. So the first one is going to be the position or the vertex coordinate. The second one is going to be text coord. We have to specify both of these so that we can use them within our shader code, and we have to give them a location, which is what this layout location does, so that we can associate VBO data with a set of data in the shader. Okay, we also have uniform variables. What's the difference between a uniform variable and a whatever whatever you call this kind of data, a non-uniform variable? Well, as the name uniform might suggest, that is a type of a piece of data that is uniform across all vertices. So the vertex shader is going to operate on every vertex, it's in the name, in the object. So this code is going to run for every vertex. Which vertex is it running on? Whichever one it gets from the vec3 position. So in that example, we had of the torus, we had 30 vertices. Okay, this is going to run 30 times. One of the times, it's going to get vec3 position 0, 0, 0. The next time, it's going to get vec position 0.02, 0, 0, whatever the other vectors are, or the other vertices are. It's going to run 30 times, each time with a different position and text chord. But some data we want to be uniform across all of the vertices, like our matrices. Our model view matrix doesn't change with each vertex. It's not dependent on the object at all. It's on the vertex information of the object at all. Same thing with our projection matrix. That's only dependent on the camera and various camera-related components. So we pass this in as a uniform variable so that it will be uniform across all of those vertices. Okay, hope I've gotten the point across. Now let's look how that relates to our GL code. So we get the uniform locations for our MV matrix and our proj matrix. So this glue int is now going to be able to tell GL where this uniform variable is. Remember that this stuff is running on the CPU, this stuff is running on the GPU. So it needs those addresses in order to be able to communicate. Then same thing with the projection matrix. We get the location of that uniform variable, and we store it for later use. Okay, now this is pretty easy. We get the view matrix, it's just the negated camera position. We get the model matrix, it's just the torus location, or position, whatever. This stuff isn't GL specific, it's just rotating the torus, and then this is creating the model view matrix. Then we get back to our GL stuff. Okay, so now that we've gotten the location for our model view matrix and the model view matrix data itself, we want to pass in that matrix to that variable. Kind of like a function call almost, or a setting function call or something. So we're going to give it the location of the of that uniform variable. Don't worry about these. And then we're going to give it the pointer to the model view matrix. Okay. Basically, all this is going to do is pass in that data to this matrix. We do the same thing for the projection matrix, and we've got our uniform data, our two matrices in there. Okay. Now, here's where we're going to do this tell GL how to read that data. So, I'm going to bind my first VBO. Remember, that is our vertex information, our position, our vertex positions. And I'm going to tell it, set what kind of data it is or how it should read the data using GL vertex attrib pointer. Now, this 0 is going to correspond with the location here. So I'm working with this VBO. I am working with location 0, and I'm telling it that it is its dimensionality is 3 because there's x, y, and z. Anytime you're giving some like per vertex info, it's normally a dimension of 3. So, you know, position is x, y, and z. Normal is x, y, and z. Maybe specular information is probably x, y, and z. However, when we do our UVs, as the name would suggest, are just u and v. So it's only 2 bits of information per vertex. So we pass it the location 1. Well, first we bind our UV VBO. We give it the location 1, and we give it the dimensionality of 2. Or, you know, there's 2 bits of information per vertex. Just like there's 3 bits of information per vertex here. Don't worry about these 4. They're usually just going to be the same as this. Then we enable that vertex attribute, and that's going to tell us, that's going to tell the shader, okay, like actually use it. Then we give it, we set an active texture to GL texture 0. I believe there's like a GL texture like 1 through, I don't know, a lot. So you can have a certain number of textures at once. We're going to say, okay, texture 0, which is going to correspond to this binding 0. Set that as the active texture, bind the brick texture to it, and then that sets that texture information in there. Then don't worry about these. This is just for depth test stuff. And then we finally are going to draw the object. So we're going to draw using triangles. I guess this isn't a triangle strip. We're going to, or maybe GL triangles is a triangle strip. I don't know. Is there like a GL strip? There's a GL triangle strip. So whatever. We're going to give it the number of indices. Don't worry about these 2 things. Just worry about this first one. So we want to draw the actual object. We have bound the VAO. We have bound our VBO3, that is the index list. Yes. And then we are drawing with that index list. Okay. Now, maybe you're wondering, why did we associate with that data with the VB? Why did we tell GL how to read that data in the display loop? The display loop gets called every frame, so it's going to happen many, many times. I'm not really sure why they did that. Usually, I just do that up here in the init, and it should just do the same thing. Yep. Maybe there's an important reason that I don't know about, but, well, if there is, I don't know about it. Okay, so we've gone through everything. We have initialized the torus. We have told it what the torus looks like and what its configuration is, and we have then passed in all of our information to the shader, and then we've used that shader to draw that torus. Okay, awesome. We're going to do one more little thing. I would like to draw a second torus. You know, 2 donuts for the price of 1. Um, Now, you might think, okay, I want a second torus, so I need a second VAO. Let me go up here and do a bunch, basically copy and paste this just with VAO 1 and make 2 VAOs. And I will say, no, 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 because I just want to draw another torus, and we already have a VAO for a torus, and I don't want to make any changes to the shape of it or the the UVs of it or the normals of it. I want to use all the same information, but I want to just draw it a second time in a separate place. So then what I can do is just create a second position, as I have done here. I've got my tor location 2 variables. I have my model mat 2 for my second torus. And now I will set the new model view matrix to be the view matrix times the second model matrix. Then I'll pass in that new MV mat to the shader. I'll pass in, well, I didn't change the projection location, so maybe I didn't even need to do that, but, I did it, whatever. And I'll tell it to draw this torus with the new information. And look at that, a second torus up in space. Oh, my skin gets really red with this light. Okay. That's pretty much it. Last thing I wanted to do is demonstrate why or what these glue ints are. So we've set a lot of, we've set our VAOs as a glue int or our VBOs as a glue int and our brick texture as a glue int. But keep in mind, this is just a reference number to GL. All of the actual information lives in GL. In fact, if I wanted to, I can just output that glue int right now. Let's see what the glue int for our first VBO is. Excuse me. And I've printed it out to the console, and it's just 1. Look at that. Not even a cool number. Same thing with VAO. What's the first VAO? The only VAO, even. Would you look at that? It's 1. So these are just a bunch of integers that start from 1 and ascend, basically, every time you generate one. And, yeah, there's nothing special about it. It's just a reference number that GL uses later. Okay, now that we've done that, and I probably took way too long getting through it, hopefully you have a fairly thorough understanding of what's going on with each of these function calls and why we're doing them. I would recommend now try changing some values, try taking some stuff out, and just see what happens, just play around. You've always got this code to come back to. So if you break it, you break it. Control Z, A lot of what I learned by just kind of tinkering around, and as long as I understood what the things that I was manipulating was, it was interesting to see how things turned out. Okay, I think that's everything. Thanks for watching. Bye.